Hello, this is Vern Danforth with the CAD office, and this recording is to cover the updates on the Chapter 10, Creating 3D Deliverable Files. Originally, this chapter was called 3D Models for Construction. The actual chapter title has been changed, and that'll be posted in the August update of the manual. It follows along with some changes that have been made in the since the 2015 CAD manual was published. We have a 2018 CAD manual now, and there are a few subtle changes, specifically when it comes to the 3D deliverables for Subgrade. So now we're adding the additional requirement that you create a 3D surface for earthwork, and that is the finished subgrade or the bottom surface to be exported as a land XML, and that can be exported from either the DSGN if that's where you did your modeling, or the MODL-RD file. And there's also some of the information in the CAD manual have been pulled out into these links here. So you're welcome to go view the CAD manual and see what those are. So for the most part, the chapter follows the same guidelines as far as creating the alignments in XML, the 2D file, essentially where you turn off different levels and different construction layers, and then create a save view or not, and then use the fence copy command to create a new DGN and DWG, or I should say DWG file, according to what's in the CAD manual. For 3D files, again, you'll need to set the final quarter stage to final, turn on and off the different features, levels, and whatnot. Use the fence copy to a new file, save as a DGN or DWG. And then for surfaces, the steps are the same. Once you have that, you can collect all those lines into a surface and then export it to a land XML. Same thing with the proposed surface. But there are a few more steps that I'm going to cover in detail. But however, I'm going to follow them for creating this proposed subgrade earthworks files. So essentially you're going to need to make sure that all your templates have point property definitions and also alternate surfaces for the subgrade points, and I'll cover that in the actual design file. And then you'll follow the same steps basically, where once you've created the corridors, you'll need to go in and set them all to final, and then turn on and off different features and levels, whatnot. Then you'll export those lines to a file, and then you'll select all those lines to create the proposed surface file for automated machine guidance. And that's actually subsurface, I should say, or the the bottom surface. And then there is a little exercise here for deleting extraneous triangles, which I'll cover. And then, just like the previous recording, there is a land XML visualizer tool that's in our workspace, and I'll briefly cover that as well. So I'm going to go ahead and get into a design file that has a finished project. Files in the roadway folder. I happen to do all the modeling in the DSGN file. Now, since then, we've made recommendations in both the design and modeling manual course guide to create 3D, an MODL-RD file for doing your 3D corridors and detail modeling. It just separates your 2D line work from your 3D model in case there was any issues with the files going forward. Sometimes there gets corrupt elements and whatnot in there. So as you can see, this is standard 4 views. I'm looking at a plan, a 3D model, a profile, a cross-section, and this project is ready for creating 3D deliverables. And specifically, it's ready for creating the deliverables for the subgrade surface. All of the other ones have been created according to the way the previous webinar was. And so what I want to cover first is what needs to be done in each of the templates. So in order to cover that, I'm going to open up the Create Template dialog, and I'm going to go over to our standard templates, or not standard, but the custom templates that were created for this particular project. And if you notice here, I have a resurfacing template for my resurfacing corridor, and a State Road 61 template for my main widening corridor, and then a rural template that I use to transition from the widening, the 4-lane divided, to the rural section. So if we just focus in on the State Road 61, what we're trying to do, and I think it was identified in the last webinar, that most of our points below the top surface are utilizing what's called a bottom PM definition. And prior to the latest release of the CAD manual, that was going to be okay, because the contractors would utilize the finished grade surface and then just use that for essentially dialing down their earthwork to figure out on their machines what the depth needed to be in order to get to the finished grade for the sidewalk. However, with the change to the CAD manual, we're starting to, or I should say, we've kind of sunsetted what was the old multi-line product, which would use cross sections and average end areas for our CEIs to compute volumes. And in lieu of that, we're using more traditional approaches with surface-to-surface volumes, or surface-to-surface cross sections. So in order to do that, we need to deliver a subgrade surface. Now, our templates aren't set up that way out of the template library, so what you need to do is go into all of the points that would be where the finished subgrade would be, and actually set the point property to a new feature here that we've included in our workspace called Subgrade PM. While you're doing that, you can also create what's called an alternate surface definition here, and this is, you can key in this subgrade name. It won't be picked from the list if it doesn't exist in your template. But once you've created it for one template or one point in this particular template, you can use it over and over. So for example, if I wanted to change this point, to use that same subgrade PM and then use the alternate surface subgrade, I'd have it there available. In this case, I don't want to do that. So once you've gone through each of your point property definitions on your template, you see that I've already got them created. Then there's a couple ways to kind of QC your templates. So for example, if I go over to my active template tab, I have a list of point features that I've used in this template. And if I click on Subgrade PM, you're going to see that I've identified all of these points that go underneath, which is really where the finished dirt elevation is for this particular project. I'm ignoring this this little foundation for this handrail because my project doesn't have that. If you did have handrails, you would need to include those, because that would be part of the finished subgrade. Notice I also have it defined up here in the median conditions. Of course, these are going to connect at this location right here, so this one is already defined at this location, which is essentially this point. It'll come up and then come across and then back down. You don't have to worry about the top surface points, because we can use the 3D features to actually build the surface. We can use these top surface features to build the subgrade surface for that. Now there is a point of clarification here, and that is where you have these base extensions, or where you have points on top of points. So for example, in this case, this sidewalk, there's a point here and then another point right underneath it. So in order to, I've done it a couple different ways, but in order to accommodate this situation, which is really a limitation in the way a typical tin model will create itself, which is what we're going to be creating eventually, and that is that they can't have what's called vertical faces, points on top of points, and they can't go back on themselves. So for example, if this is a triangle file that comes down essentially almost vertical, not quite, it comes across, the same thing here, it can't go back on itself, or what's called a cave. So in order to accommodate this template for a subgrade, I'm ignoring these base points right here. Now that's going to give me a little bit of a, it's not exactly accurate for that base extension, but it's as good as we can do with template designs. The other thing you'll note is whenever there's a point that looks like it's truly vertical, what I've actually done is I've gone in and created an offset. So if you look at this point, it's set to -42. However, this point right here, which is typically right below it at a horizontal offset of 0, is now got a small offset to the side that the triangle would form. So in this case, it's a plus 0.01. And that'll prevent it from being a truly vertical surface. It just needs a small horizontal distance in order for that to be created. And I've done the same thing on this point down here. You'll notice that it's also got a 0.01, so it makes it an offset of -41.98, where this one up here is 42, and this is -41.99. So these points will form along a almost vertical but not exactly vertical surface. What I did over on this side is I went ahead and added a point on the flat sod surface, if you will, and I did that by right-clicking and doing insert point. And once I created it, then I went ahead and set the constraints, and I'll show you how these are set. So this is set at 0.05. Negative 0.05. That's another way of doing this. I could have set it to 0.01, as close as 0.01. And I also gave it a name called subgrade intersection, or X in this case. And notice I'm also using the subgrade PM and the subgrade alternate surface. Okay. So this is just another way of doing it. When you intersect a top surface, I'm just creating an additional point here. You could have done the same thing if this was a shoulder, and I actually have a template that has a shoulder, and I'll show you that in a second. But before I go show you that particular template, I want to show you one other thing, and that is you can validate both your surface feature points by clicking on here and going through and look at these and make sure that you have included all of the points necessary. And I should say, you can also click on the alternate surface, so subgrade. You may see in some of your templates that there's a stabilization alternate surface. I would delete those in your template because those were from a previous definition, and they're not accurate enough for really a subgrade surface, as we've come to find out. So we're going through our template library and deleting those. Okay, so let me show you another template where these have been set up. I'm going to go to this State Road 61 Rural. I'll go to the Active Template tab again, and I'm going to show you my point feature definitions for subgrade. And you see I pretty much set it up the same way. Now in this case, you can see that I'm ignoring my base extension here, and at the pavement layer I've got another point which is the same way, a vector offset on this vector at a distance away of 0.05 feet. I could have done this in a different way. I could have actually used these base extension points and made sure that these two weren't right on top of one another, and then did another intercept on this away from this point here. So if you feel like that's more accurate, you're more than welcome to do that. Over here, I'm just going from, again, I'm ignoring the base extension. I'm going from this point to this point and then down to this point. And I will have a similar alternate surface for subgrade, and that's what will define those alternate surfaces. You'll need to do this on all of the templates that are in your project in order to get these. Now on this this is a resurfacing type template with widening on both sides and full new shoulders. So if you look at the definitions in this case, I've got the point property definitions defined here, and let me squash this template up a little bit so you can see what's really happening. So what's happening in here is the same thing I did on that other shoulder, where I'm coming down, ignoring the base extension, coming across, and then this point actually should have a point property. Actually, no, this is a base extension, which is why it's not. So when you blow it up, it looks a lot more. So I tried to follow the same convention. I collect this point right here, and then this one come down for the widening, because this is actually a widening. So if this were to widen out, you'd see that it would come down and pick up the widening, but it ignores the base extension of the actual 4 inches there. But then it comes back up, and eventually it ties back into the bottom of the milling layer there. So the widening comes up for the base, and then it comes back up to where the milling is. And that's how it's defined on this particular template. I've also got linear templates. So on my project, around all my intersection radiuses, I have different templates that I'm using. So in order to accommodate those, I have to go through the same setup where I set up the subgrade feature definition, and I'm also doing the subgrade. Here's a case where I didn't delete out the stabilization. You can see that it's got not all the points, so what I'd want to do is delete that one and just use the subgrade definition, which comes down across according to the way I want to do it. Again, I think these are going to have to be done by a project by project basis. Once you've done one, it takes about, it takes a little bit of time to go in and get these all set up, but it'll definitely be useful for what we deliver to the contractor. Same thing with all these with these linear templates, and then also your surface templates. If you open those up, any surface template that you're using also needs to have those points defined. So I've also got point feature definitions set up for subgrade here on these 2 points. You really only need it on one, but I did it on both sides. And I actually have a resurfacing template that I'm using for one small segment of it, so I also had to do it on this particular template. I have a subgrade point defined down here, and also an alternate surface point defined at the same location. So that covers the changes that need to be made in the templates. So I'll go ahead and save this, and then you would go in and have to go into each one of your corridors and synchronize the templates. So in this case, I've got for my corridors, I have 2 corridors here, and I'd need to synchronize all 3 of these template drops in order to get all the changes. Same thing with my State Road 61 corridor, have to resynchronize those. Any of the linear templates, go through and synchronize any of these that I'm using, not the driveway ones, but in this case I'd need them for these areas along here. And then for your surface templates, those are in the terrain models, so you would need to come into your terrain models, and actually you can right click and synchronize these templates as well. The other thing that you'll need to do with the terrain models is you'll need to open up the point properties dialog for each of these. I'm sorry, the template property dialogs. So if you go to Control I or element info, and then click on the surface template, there is a create linear features option, which is typically set to false, and those will all need to be set to true. And what that does is when the surface template is then created in your model, it actually draws the linear features of the points. Otherwise, it just creates the mesh. So you want that boundary line, that 3D boundary line, to be created so that you can use that as a 3D line in these intersect areas. So that's the other thing that you'll need to do for each of these surface templates. So you'll see that I've got those. So once you have those, then the next step is to prepare the view that you want to export. So in order to do that, I'm going to close out these other views and just focus in on the 3D view. And just like in the previous webinar, what you'll want to do is go in and turn off any reference files that are not associated with these 3D subsurface lines. So in this case, I don't need my existing terrain turned on, I don't need the existing features turned on, and these cross-section super elevation shapes, I don't need those turned on as well. From there, you go into Project Explorer, go to the Civil Standard tab, and if you go into the design file, go under Feature Definitions, you'll see that you have all these folders. So the ones that we want to turn off are going to be all of the corridor components, because those are going to have all of the mesh objects, and you'll notice that they turn off, everything turns off. And if you look at my corridor 3 lines, they're all turned off right now, so I'm going to turn all those on. It'll take a second for those all to turn on, I believe. Yep. And then close that for now, and I'm going to turn off all of the planned 2D lines, because this is there's actually 3D lines that are generated whenever you make a profile active from a 2D line. So for example, your center line, this line right here, is created from when I made the profile active for this particular line in the plan view. So if I uncheck that box, I will turn off anything that is created from a center line or an edge of pavement line or something like that. What we're wanting to use are just the points that are created, or just the lines that are created from points on a template. So that'll turn all those off. The other thing that you'll want to turn off is any terrains that you have turned on in this view. In this case, I don't have any turned on, but if I had, for example, the DTM proposed for that intersection and I had constructions, you see what I'm talking about? These are terrains that are created during the detail modeling. So you can uncheck those and it'll turn those off. The last thing you want to check is, well, of course, you want to turn off any construction elements that you might have in this 3D view. And then I always go and look at the levels to see if there's anything else in here that I don't want on. For example, these default lines, I don't want those on. I don't want the construction lines or construction line PMs on. Any scratch layers, any miscellaneous level layers, and a lot of these turn off when you turn off the features, so you don't have to turn all of them off, but you'll want to be very meticulous about which of these you want turned on. And the one thing I forgot to do was to go back to the 3D folder, and the only lines that I'm going to want turned on in this case are cut lines, shoulder unpaved lines, and the subgrade lines, and actually the median crown lines. So it's easier just to turn them all off and then turn them on. Now you do see these little gnats out here, but if you zoom in, they're just ghost elements. So first thing I'm going to turn on is all the subgrade lines. And these come in at the feature subgrade PM, which is purple. And then I'm going to turn on the cut lines, which are the boundaries on the outside, and the fill lines, and then also the median crown. So there's a median crown line down the middle here that'll need to be part of the top part of the finished earth surface. And then there are shoulder unpaved break lines, which are outside of the paved shoulder, which is where I'm intercepting from my subgrade up to that line. And that will create all the necessary lines, and none of them will be stacked on top of one another. And if you look at them down here, you'll start to see what those lines look like. And if you kind of read over here, you can see that it's going to go from a fill to this unpaved, hit the shoulder, sidewalk, go down underneath the sidewalk, and then eventually it finds the base, and it'll go across to the other base, and so on and so forth. And so once you have those, the next step would be to actually export these to a DGN file. So that is the same steps that we normally do, which is to create a fence, select the fence around all my elements, and then use the copy move fence contents to file. And then you want to locate the 3D deliverable folder and select the name of the file you want to put these in. Now we don't have a specific name for you to use for the subgrade lines. And actually, let me go back to my slides here and see if there was a specific file for the 3D lines. So we have it defined for the proposed break lines, and so you see here how we're defining PR for the XML of the finished terrain and an EW for earthwork for the finished terrain of the subgrade. But these 3D break lines, right now we just have 3D DSGN hashtag. I suppose you could use EW here as well, and that would give them the 3D lines in addition to the terrain that goes with it. So in order to do that, let me just go ahead and select this one, and I'll set this to DGN EW earthwork 01, and we'll save this file and then accept the fence contents, and the file was created. From there, you can go into that file and verify those lines are created in the file. Now again, what we're doing is we're actually saving these to a by doing this file fence save as, whoops, we're actually stripping all the civil intelligence off of these lines. So this is the file that I just created. You can see that I used a different name, subgrade, but I kind of like that EW. And all that should be in here are just these 3D lines. So I can turn off all these other views and just expand this view. And then this is also where you could go in and save it to a DWG file. And I'll tell you a little trick, and that is like, for example, you have some of these lines that are extending farther than they need to be. If you were to try to use the modify tools and try to delete these vertices on these lines, well, in this case it's going to. So you could delete out some of these. It used to be you had to do this from a DGN mode, but it looks like, yeah, see, like sometimes they will delete and sometimes they won't. But one thing I have found is if you save this file, do a save as, and select that same file name but change it to a DWG file and save this file, it will convert these to a DWG level elements, and you want to select always accept US survey feet there. And the color table is a little different, but it's okay as long as we're on the right level. Now you can go in and use that same delete vertice tool, and it works a lot more. For some reason it seems to work better with a DWG mode to delete these out. So there's some areas here that you want to delete out. So anytime you want to, there's a crossing break line somewhere like over here, sometimes it's not as easy to do it in the template, so it's easier to just do it from deleting vertices to get cleaner surfaces. Here's another one where I probably would just delete that whole element. And once you've finished basically cleaning up the file, there's another issue over here. You might want to probably need to delete either this vertice or maybe this whole segment here. I'm not sure. Without looking at it in 3D, you can see that there's two different versions of what the subgrade is trying to do. One from this surface template and one from the actual template. So in that case, you might want to move this point. So if you pick this element, you might need to move it back to somewhere around in here, something like that, to make it a little cleaner. Like I said, once you get back to all your finished edits, then you can do a file save as, and you can save right back to a DGN and just overwrite that DGN that you already created. So assuming that this file has the edits made to it and I saved it off in the right version and so on and so forth, then what you would do next is, now you can do this a couple of different ways. I think in the last webinar they had us, or we had you going into the create new file, creating an AMG file, AMGRD file, and then referencing in the 3D line work to get the proposed surface. You could create this terrain in the same file. So essentially you just create a selection set of everything and then go to the terrain tools and you'll create from elements here. And then you'll use the DTM proposed, and I believe the name that we're using is and there's no XML in this case. So that's the name of the file that or the name of the surf terrain that we're going to create. And whenever you change, or whenever you add a field here, you got to make sure you change the focus in order for it to take. Now in this case I'm using all break lines and there's no edge method. In the past I think we were having you put in a max triangle length, but I'm going to show you a little different way of doing that. So there's 197 elements, break lines, edge method none, and it will create the terrain. Now you'll see right away that the terrain is falling outside of the boundaries, right? So the easiest way to correct this is to use the tool here for changing these feature types. Now for the proposed surface we were able to go in and just isolate the levels, turn everything off except for the cut fill lines, and then selecting all of them and adding them all at one time. However, I'll show you what happens when you do that. So now I'm going to go back to the levels and turn on, well, before I do that, let me create a selection set of all these. And then I'll turn on the level for the triangles. And then I'll use this tool, and it says there's 34 cut fill elements, and I want to use them as a boundary on this terrain. It already knows that they belong to this terrain. So if I just go ahead and data point and select the boundary, you'll see what happens is it's not getting, the way it's trying to form the boundaries, it's not working properly. So I'm going to do a Control Z and take those boundary elements away, and then go back to my levels and turn off these triangles, and then I'm going to select them. Instead of doing it from a selection set, I've shown you the issue with trying to use the cut fill lines. Now I'm going to show you another way to edit out these extraneous triangles. So if you click on this terrain, you can go to the rules and you can remove the rules that it's associated with just these break line elements. Now it's still going to, the terrain is still valid, but what I'm going to do now is delete out triangles. So some of you may be using this tool already, but once you've selected the terrain, you can go in and use this delete by triangles, and you can clear out a lot of these really fast. So I can just select a line, and I can get into as close as I want with this until I clean out all those triangles on that corner, and do the same thing over here. And you'll see you can get right to the nearest triangle of that cut fill boundary element, which is right there. And essentially go through all of your corners like this until you get them all deleted. And there'll be some other areas like this that you'll need to clean out. And you'll just go around until you've got all of those cleaned out. There's obviously some more up here. As soon as you get to a break line, it won't let you delete any other triangles after that, so you don't have to be as careful as you think, because those are break line elements. And you'll just go around and trim all those out. And that's how you'll build that surface. And if you rotate it around now, you can kind of look at it and see what that bottom surface does look like. And this creates the full bottom surface. If you were to use the alternate surfaces, you can create those also in the other file if you've only got a couple of simple corridors. So for example, well, before I go to show you that, let me go ahead and save this terrain, which is the last step, which is where you just come over here and do the export to land XML, and then give it the name, and you're going to export both. It's going to be a proposed surface, and you're going to create this file, AMG3 surface EW, and save that file. And I'm not going to show you that tool, but there is a analyze volumes tool right here where you can do terrain to terrain volumes, and most of the contemporary civil engineering design software has this ability to go terrain to terrain, as in addition to like average end area on projects. Because now the contractor can get the existing ground, the subgrade ground surface, and the proposed grade surface, and if he wanted to cut cross sections and validate what the average end area was, or if he wanted to do terrain to terrain surfaces, he could do that as well. I was just going to show you that the alternate surfaces will also create meshes and terrains. So if you go back to the design file here, so if I were to go to the terrain tools, create alternate surfaces, you do this by corridors, okay? And let me go ahead and delete this one here, which is for State Road 61 subgrade. If I just delete this surface, so that's an alternate surface, and I'll recreate it. So if you come over here to the terrain models and go to create alternate surfaces, you're going to pick on the terrain boundary, and it will go out and process all of those points that are defined for subgrade, and it actually creates a terrain out there for you. So on simple projects where you don't have a lot of detail modeling, and notice that it used this active level, where you don't have a lot of detail modeling and it's just one straight corridor, you can just use this terrain because it comes from the alternate surface tool. And then this terrain here can then be exported just like any other terrain to a land XML file. But if you've got detail areas that are added to your corridor, then you'll have to go in and do this other method of using the break lines to create that. And again, this subgrade surface, I didn't include my my cut and fill line, so I would have to go in and define those points on my template if I knew I was just going to use one alternate surface to define what this terrain was going to be. Okay, so that is the details for creating the subgrade surface. This will be the end of the recording.